Hello guys, welcome back to the reaction zone. In today's lesson, we're going to solve the problem on the board using stoichiometry. And the question is as follows. Calculate the volume of hydrogen liberated at 27 degrees Celsius and 760 millimeter mercury by treating 1.2 grams of magnesium with excess of hydrochloric acid. To solve this particular problem, the first thing that we need to find is the volume of hydrogen that is liberated at standard temperature and pressure by reacting 1.2 grams of magnesium with hydrochloric acid. Only when we get that can we now find the volume of hydrogen liberated at 27 degrees Celsius and 760 millimeter mercury. Now, when we look at the value of temperature and pressure in the question, the value of pressure is standard pressure in millimeters mercury. But this value of temperature is not standard temperature. So before we can find the volume of hydrogen that is going to be liberated at this particular temperature and this particular pressure, we need to first of all find the volume of hydrogen that will be liberated by 1.2 grams of magnesium at standard temperature and pressure. So that's the first thing we need to find before we can get the answer to the question. Now, looking at the balanced chemical equation, the mass of magnesium here is 24 grams. The mass of the number of moles of hydrogen is 1 mole. Remember that the first thing we want to find is the volume of hydrogen that will be liberated by 1.2 grams of magnesium at standard temperature and pressure. This 1 mole of hydrogen at STP, that is standard temperature and pressure, has a value of 22.4 liters. So, it means that from the balanced chemical equation, we can say that 24 grams of magnesium will liberate 22.4 liters of hydrogen at standard temperature and pressure. So, 24 grams of magnesium liberates 22.4 liters of hydrogen at standard temperature and pressure, STP. So like I said, the first thing we need to find is the volume of hydrogen that will be liberated at STP by 1.2 grams of magnesium. So, if 1.2 grams of magnesium liberates X liters of hydrogen at STP, what will be the value of X? Cross multiply. X times 24 is going to be equal to 1.2 times 22.4. X is going to become 1.2 times 22.4 over 24. And this is going to give us 1.12 liters. So what this means is that the volume of hydrogen that will be liberated by 1.2 grams of magnesium at standard temperature and pressure is 1.12 liters. Now that this is clear, we can now find the volume of hydrogen that is liberated by 1.2 grams of magnesium at 27 degrees Celsius and 760 millimeter mercury. To do that, we have to make use of the general gas equation. And we're going to have initial conditions and final conditions. The initial conditions will be the conditions at standard temperature and pressure. So, our P1 is going to be the value of standard pressure, which is 760 millimeter mercury. Our T1 is going to be the value of standard temperature, which is 273 Kelvin. our V1 is going to be the volume of hydrogen liberated at standard temperature and pressure, which is 1.12 liters. Our P2, which is our final pressure, will be the pressure in question. That is 760 millimeter mercury. Our T2 is going to be the temperature in the question, which is 27 degrees Celsius converted to Kelvin by adding 273 will give us 300 Kelvin. And then V2 is the volume that we are looking for, which is the volume of hydrogen liberated by 1.2 grams of magnesium at 27 degrees Celsius and 760 millimeters mercury. So using the general gas equation, P1 V1 over T1 will be equal to P2 V2 over T2. When you cross multiply, you have P1 V1 T2 is equal to P2 V2 T1. And when you make V2 the subject, V2 will become P1 V1 T2 over P2 T1. Putting the values of the parameters, P1 is 760, V1 is 1.12, T2 is 300, P2 is 760, and T1 is 273. Now this cancels this, and the value of V2 will be 1.23 liters. So this means that the volume of hydrogen liberated at 27 degrees Celsius and 760 millimeter mercury by 1.2 grams of magnesium, when it is reacted with excess of hydrochloric acid, will be 1.23 liters. Thank you very much for viewing, and see you in the next lesson.